Hello and welcome to today's video lecture of Object-Oriented Programming using Java. Myself Shaini Chandro, Assistant Professor of Department of Computer Science and Engineering of Guru Nanak Institute of Technology. So let's look at today's lecture contents. Today we will be learning about literals used in Java programs. Then we will be learning some example programs that will be done using Java language. And lastly, we will learn scope and lifetime of variables that are being used in Java language. So let us first learn about literals in Java. Any constant value which can be assigned to the variable is called as a literal or a constant in Java. So let's understand the concept with an example. Suppose we have declared a variable like this. And then we have assigned a value 100 into this variable. Then this is the variable declaration statement which will actually declare the variable x, and this is the value assignment statement which will assign a value 100 into the variable x. Now this 100 value is a value which is a constant value which is known as integer literal. This literal value can be assigned into a variable x. That's why this value is known as a literal value or a constant value. Now, there are many types of literals available in Java. The first one that we will learn today is integer literals. We know that integers are of four types in Java: byte, short, int, long. Integer is the primitive data type that is available in Java, and there are four integer data types, namely byte, short, int, long. We can specify the integer literals in four ways. Let us look at those four ways with examples. The first way is decimal literals. Now we know that decimal numbers have a base 10, and the allowed range in case of decimal numbers is from 0 to 9. So if we declare an integer literal like this, then this 101 or 101 can be treated as a decimal integer literal, because we can see that this 101 is completely within the range of 0 to 9. So this can be treated as an integer literal which is of decimal type. Similarly, another integer literal of decimal type can be written as, say, 456. This 456 is completely within the range of 0 to 9. So this can also be treated as an integer literal which is of decimal type. The next one is octal literals. We know that in case of octal numbers, the base is 8 and the range is from 0 to 7. So if I declare an integer literal like this, then this can be treated as an octal integer literal. Now why this 0? This preceding 0 indicates that this integer literal is of octal form, or more specifically, this is an octal literal. So in order to define an octal literal, you have to prefix the octal number with a 0. That means this is the literal value and this is the prefix which is added before the octal number in order to indicate that this whole number is an octal literal. And this 146 is the octal literal value itself. Now we know that the range of octal numbers is from 0 to 7. So 146 is perfectly within this range. That means this 146 value can be treated as an octal literal. The next one is hexadecimal literal. Now we know that in case of hexadecimal numbers, the base is 16 and the range is from 0 to 9 and from A to F. We know that the values from 10 to 15 are written using the letters A to F in case of hexadecimal numbers. The base is 16 here and 0 to 9 is also within the range. So actually the range is from 0 to 15. That means base is 16. The first 10 numbers are written within this range using these digits from 0 to 9, and the next numbers from 10 to 15 are written using these characters, which is of the range A to F. Now Java is a case sensitive language. That means we can use certain characters in upper cases or lower cases as specified. But although Java is a case sensitive programming language, here Java is not case sensitive. That means we can either write A to F, or we can also use the small letters small a to small f. That means this is also a valid range and this is also a valid range. This is perfectly valid and this is also perfectly valid. Both these ranges of hexadecimal literals are valid because Java doesn't work like a case sensitive language here in this case of defining hexadecimal literals. So this or small a to small f both are perfectly okay when defining ranges of hexadecimal literals. Now let's declare a hexadecimal literal. Now see this 123F, this is the hexadecimal literal value, and this 0x, this preceding 0x indicates that this is a hexadecimal literal. That means just like octal literal, in case of octal literals you have seen that we are prefixing the octal literal value with a 0 in order to indicate that this is an octal literal, and in order to indicate that this is a hexadecimal literal we are prefixing the value of the literal with 0x. The 0x indicates that this is a hexadecimal literal. Same is the case with here also, you can write it either in small letter or in capital letter. Both are valid. That means if you write another hexadecimal literal like 0x45fa3, then this is also valid. Whether you write this x in small letter or capital letter, both are valid, because I have already told that Java will not work as a case sensitive language here in this case of defining hexadecimal literals. So both these definitions of 0 small x or 0 capital X are valid. This is used mainly to indicate that this is a hexadecimal literal. This 0 capital X is also used to indicate that this is a hexadecimal literal. The last one is binary literal. Now from Java version 1.7 onwards, we can specify literals value even in binary form also. Now we know that in case of binary numbers, the base is 2 and the only allowed digits are 0 and 1. In case of binary literals, the prefix should be 0b or 0 capital B. Both the small and capital letters are allowed because of the same reason why hexadecimal numbers or literals can be prefixed with 0 small x or 0 capital X, because Java will not work as a case sensitive language here. So prefixing the binary literals with 0 small b or 0 capital B both are allowed. So let us write an example of a binary literal. This is a binary literal with the value 111 and the prefixed value 0b indicates that this is a binary literal. Similarly, if I write another binary literal like 010, This is also a binary literal where the value of the literal is 010, and this prefix or this preceding 0b indicates that this is a binary literal. So these are the four ways how we can declare integer literals: by using decimal literals, by using octal literals, by using hexadecimal literals, and by using binary literals. Let's go back to our slide to learn the next literal. So we have learned integer literals till now. But one thing to be noted is that by default, every literal is of int type. We can specify explicitly as long type by suffixing the literal values with small l or capital L. But there is no way to specify byte and short literals explicitly. But indirectly, obviously, we can specify. Whenever we are assigning integer literal to the byte variable, and if the value is within the range of the byte data type, then the compiler will treat that variable automatically as byte literals. That means, suppose we are writing a literal value which is within the range of the byte variable, and we know that the range of the byte variable is minus 128 to plus 127. If we write an integer literal value that is stored within a variable that is within the range of the byte data type, then compiler will automatically assume that that literal is a byte literal. Okay, so let's move on to the next literal, which is floating point literals. Now for floating point data types, we know that only two data types are there under this floating point category, which is float data type and double data type. Now we can specify floating point literals in only decimal form, but we cannot specify these floating point literals in octal and hexadecimal forms. So let's look at this floating point literals with an example. So we have already told that floating point literals can only be described using decimal literals. Now we have already learned decimal literals, and we already told you that decimal literals have a base 10 and the range is 0 to 9. So if I declare a double variable d like this, and if I put a value 123.456 into it, then this literal value is a floating point literal value, which is perfectly within the range of these decimal numbers. So here we have shown that a floating point literal can be written like this using decimal literals concept, where the range should be within this 0 to 9. This value is assigned into the variable d, which is of double type. So this is treated as a floating point literal. Now, by default, every floating point literal is of double type, and hence we cannot assign directly to float variables. But we can specify floating point literal as float type by suffixing with small f or capital F, just like long data type. We can specify explicitly floating point literal as double type also by suffixing with small d or capital D. Of course, this convention is not required. So let's go back to this current slide in order to learn the next literal. So till now we have learned integer literals and floating point literals. Next we will be learning Boolean literals. Now we know that Boolean data type can hold only two values, true and false. Same is the case with Boolean literals also. Only two values are allowed for Boolean literals, which are true and false. Let's understand this with an example. Suppose we are declaring a boolean variable as b. This b is a boolean variable because the data type mentioned here is boolean. So we can only assign two values, true or false, into it. Like we have assigned the value true into the boolean variable b. Let's take another boolean variable, say bb. and we have assigned another boolean value which is false into this variable bb. So we have seen that only these two values can be assigned into boolean variables, just like boolean data types. So these two values, true and false, these two values are boolean literals. These two values are known as boolean literals that can be assigned into boolean data types, sorry, boolean variables. Let's go back to the slide to learn the next literal. So we have learned till now these three literals. Next, let's learn character literals. Now, in case of character data types or character literals also, we can specify the literals in 4 ways. So let's learn the 4 ways to specify char literals or character literals. The first way is by using single quote. Now let's understand it with an example. Suppose we have written or we have declared a character like this. Char ch is the variable name, char is the data type, and we have put a value or a single character a into the variable ch. Now we can see that the character has been enclosed within single quotes. Now this a, the single character a, can be considered as a character literal. And by enclosing it within single quotes is a way of specifying character literals. The first way of specifying character literals is by using single quotes. So if you want to assign a single character into a char variable, then you have to enclose it within single quotes. If you don't enclose it within single quotes, then compiler will not treat this as a character literal. If you are assigning a single character or a single any alphanumeric character also into a character variable which is ch, you have to enclose it within single quotes. So by using single quotes is a way of specifying character literal. The next way of specifying character literal as integer literal. That means the character literals can also be specified as integer literals. So we can specify character literal as integer literals, which represents the Unicode value of the character, and that integer literals can be specified either in decimal or octal or hexadecimal forms. But the allowed range is 0 to 65535. We know that char data types are internally interpreted by Unicode in case of Java. So if we write, for example, char ch equal to 062, then the 62 is an integer value and the 0 indicates that it is in octal form, like we have just discussed in case of integer literals, that if you are using the octal literals, then you have to precede it with a 0. You have to prefix the value of the octal variable with a 0. So this is the value of the octal literal, which is 62, and the prefix 0 means that this is an octal literal. That means this 62 is an integer value, but internally it will be treated as a Unicode value, and whenever you want to print the value of the char variable ch, the character equivalent of the Unicode value 62 will be printed on screen. So basically we are using an integer literal, more specifically we are using an octal literal here in this definition, and this octal literal value or integer literal value is internally treated as a Unicode value, and the corresponding character of this Unicode value will be displayed on screen if you want to print the value of the variable ch. So character literals that means can also be represented as integer literals, and decimal literals, octal literals, and hexadecimal literals are the three ways to represent character literals as integer literals. Here we have used the octal literals representation. The next one is Unicode representation. Directly we are using the Unicode. So let's see with an example how we can represent character literals using Unicode directly. Now here we have written a syntax. Here these four M's, represents four hexadecimal numbers. And this /u indicates that this is a Unicode value. Suppose, for example, this is the syntax and I'm now writing an example, say /u0061. This /u0061, this whole thing represents a Unicode value of the character A, small a. This whole thing is the Unicode value of the character small a. So that means we have used the Unicode representation of the small letter of this letter small a. This Unicode value will be interpreted internally, and whenever we want to print the value of the character ch, of the value of the variable ch, the value that will be printed on screen is a, because we have used the Unicode value of this letter small a directly in our program in order to indicate it as a character literal. So we can also use the Unicode representation directly in order to represent the character literals. And here these values from 0 to 1, 0061, these four characters represents the hexadecimal numbers which is contained within the Unicode representation of the character small a. The next one, which is escape sequence. Now we have already learned about escape sequences in case of C language or C++ language. In case of escape sequence, you have learned that whatever be the escape sequence, that particular part will be escaped. And we have already told that in case of Java language also, all the escape sequences that you have learned in C language are present. So you can also use those escape sequences as character literals. Let's see with an example how. Suppose we have used the escape sequence /n, which means new line. This /n, this whole thing is used, this /n is used as escape sequence or new line escape sequence, which is enclosed within single quotes. Enclosed within single quotes mean that it is a character literal. This character literal is then stored into the character variable ch. That means whenever you want to print this value of the character variable, that will give you a new line, nothing else. So the escape sequences can also be used as character literals. Here we have used the new line escape sequence. You can also use other escape sequences like /b or /t or any other escape sequences that are available. All of those will be displayed on screen whenever you want to print the value of this variable. So these are the four ways how you can represent the character literals in Java. Let's go back to the slide to learn the next literal. So till now we have learned integer literals, floating point literals, boolean literals and character literals. Next we will be learning string literals. So string literals are basically any sequence of characters within double quotes. That means let's look at an example. Suppose I am declaring a string type variable. We have already discussed a bit about the string class. We have already told you that in case of C language, you have learned that character arrays and after that a null character will comprise of strings, character arrays. Then a null character appended after that will be treated as a string in case of C language. But in case of Java language, character arrays are completely character arrays which can be used to insert or input some characters into it. But strings which can be manipulated by the users are completely objects that can be derived from the string class. Whatever objects of the string class you made can be treated as user defined strings. So we will discuss about strings in detail in the string chapter. So as of now, this is the concept of the string that you have to keep in mind. Suppose I am taking a variable s which is of string class type, and into it I am assigning some value, say hello. Suppose hello is a text or word that I want to assign into the string variable s. Now this variable is a special type variable which is not like any other variables in Java. That also we will discuss in detail when we will be discussing about how to create objects using Java codes or how to create classes. As of now, you just keep in mind that this is a simple text or word that we want to assign into the variable s, and this s variable is of string class type. Now we have shown here that this text or this word is enclosed within double quotes. In case of char literal, we have seen that a single character, if you want to treat it as a character literal, you have to enclose it within single quotes. Here we are using multiple characters, which is a word or a text or a string. Then in order to use such kind of texts in your program as a literal, you have to enclose it within double quotes. So whatever string or texts or combination of words or sentences you use in your program which should be considered as a literal, you have to enclose them within double quotes. That means the value hello will be assigned into the variable s if you print the value of it. Let's see another example. Suppose we have forgotten to write the double quotes. Now what will happen? This statement will give you an error if you want to print the value of S1. Why? Because there are no double quotes. That means the compiler will not assume this hello as a string literal. Here it is a string literal, but here it is not a string literal because it is not enclosed within double quotes. So this will be treated as a normal variable. This will be treated as a normal variable by the Java compiler javac. So the compiler will assume that hello is a variable and its value has to be assigned into the string variable s1, which is not the case. Hello is not a variable and it is not declared anywhere in the program. So the compiler will want to find the variable hello, and then the compiler will want to assign the value of the variable hello into s1, but hello is not declared as a variable in this program, so the compiler can never find the variable hello, and it will give an error, which is a compile time error. So you have to keep in mind that if you want to make some text to be treated as a string literal, you have to enclose it within double quotes. Otherwise, this will give you error. Let's take another example. Say S2, and I'm writing a sentence, a large sentence, which should be treated as a string literal. So here you can see that there is a single statement that I have written in 3 lines. This is a string literal which spans across 3 lines. Now the first string that I have written within a pair of double quotes is this is a string literal. Then after that a new line is there. Then after that a plus sign is there. I have already discussed about this plus sign in the last lecture. This plus sign will actually concatenate strings. That means this string, this is a string literal, then a new line. This whole string written within double quotes will be concatenated with this string, which spans across new line. That means this string, which spans across new line, will be concatenated or appended after this new line. Similarly, this plus sign will also concatenate these two strings. That means 3 lines, full stop, after that a new line, this whole string will be concatenated or appended after this new line. So if you print the value of s2 variable, this will give you this is a string literal in new line which spans across a new line again, 3 lines, full stop, then a new line again, there the cursor will blink. So this will be the value of the variable s2 if you print it. Let's go back to the slide again. So till now we have learned about 5 types of literals that are available in Java. These are the 5 types of literals that are available in Java, and we have learned all of them and how to specify them in many different ways. Let's move on to the next slide. So this slide will give you some example programs. So this is a simple program that will print the value of the variable num at first. Then after that some manipulations will happen, and after that the value of the same variable will be printed. So let's understand this program statement by statement. So here we have defined the class example. The class name is example. You can give any name. We have given the name example. After that the main method is declared. This main method I have already explained in the last class. Each of the words in the main method I have explained in the last class. So I'm going into it. Inside the main method, there is a variable declared as num. Num is an integer type variable because its data type is int. So this num variable can hold only integers. In the next statement, num equal to 100. That means the integer literal 100 is assigned into the variable num. Now, the variable declaration and the value assignment statements are written in 2 statements. The same can be done in 1 statement also. Let's see how. So let me first write what was written inside the code. So inside the code, this was the variable declaration statement written, and after that, a value assignment statement was written. So instead of these two statements, you can also write it in one statement like this. This is called variable initialization statement. That means the value is assigned into the variable whenever it is declared. You can also write it like this, or you can also use two statements like this to declare the same. In the next statement, we have just printed the value of the variable num. Now this type or this syntax of printing I have already discussed in the last class. This system.out.println will actually print something on screen. This part is enclosed within double quotes. That means this part will be printed on screen. After that, a plus is there. That means after this string, which is enclosed within double quotes, the value of the variable num will be appended or concatenated. The value of the variable means 100. There are no ways to define format specifiers in Java. So we will directly write down the value name of the variable. Remember that you don't need to enclose it within double quotes because you want to fetch its value, not the variable name itself. So this statement will give you the output. This is num colon. After that a space will be displayed because it is given here. And after that the value of the variable, which is 100, will be given. Now see, there is a space before plus, there is a space after plus also. These spaces will not be treated because they are not given inside double quotes. Whatever spaces are given within double quotes will only be treated as a character that will be shown on screen, and whatever spaces are given outside the double quotes will not be treated. In the next statement, there is a manipulation statement. The value of the variable num has been multiplied with 2 and the same has been stored into the same variable num. So the variable num now contains the value 200. 100 multiplied with 2 will give you 200 into the same variable num. In the next statement, there are two statements to print the value. In the first statement, it will just print this statement on screen. The value of num into 2 is space. That means this system.out.print statement will just print the value, this value which is enclosed within double quotes on screen. After that, the value of the num variable will be printed because there is no new line. So after this space, directly the value of the num variable will be printed. No new line will be there. So after this num variable's value has been printed here, there is a ln mentioned here after this print method. So the cursor will go to the next line and it will blink there. Now let's go to the program and let's check how it can compile and execute to give you the output. So the same program I have already written and I have already saved it in desktop. So let's see how it gives you the output. So let's first compile it using the statement javac. I have saved the file using the name example.java. Because the main class name is example, that's why I have saved the file using the name example.java. So now I am compiling it using the statement javac space example.java. Enter. No errors are there. That means compilation is successful. So now execute the program using java space main class name, which is example. Now you can see the same output is produced that I have just told. This is num colon 100. The value of num into 2 is 200. And then after that a new line is displayed. This new line is displayed because of this ln. This new line is displayed because of this ln. If you give a ln here, then after this statement is displayed, there will be a new line, and in the new line the value of the num will be displayed. As we have not given any new line here or any ln here, so the value of the variable num will be printed here just after this statement. So this is the explanation of this program. Now let's move on to the next program. So in the next program, we will see how the scope and lifetime of variables used in Java languages can be treated. So this is an example program that will show you the scope and lifetime of two variables x and y. Let's understand the program step by step. So the name of the class is scope. You can give any other name of this class. I have just given a random name scope. Then I have defined the main method. After that, the main method brace opening brace is starting, and inside that a variable x is declared. Now see, this variable x is declared within the main method block. You already know what is a block. Opening closing parenthesis will comprise a block. So this x is a variable which is declared within the main method. And we know that any variable declared within a method is known as a local variable. So x is a local variable here. Now, after that, a value 10 has been assigned into the variable x. Now, we have already told you that all the decision making structures and all the loop control structures that you have learned in C languages are there in Java language also. There are some other variations that we will obviously learn, but as of now, just keep in mind that all the decision making structures like simple if, then if else, then else if ladder, then nested if else, all those things are there in Java also. Here we have used a simple if structure. This is the if block and this is the condition if x equal to 10. Now the value of x is 10, so the condition is satisfied. So this if block satisfies means that it will enter into the if block. Now this is the if block. This opening closing parenthesis marks the block of the if statement. This is the if block. Inside the if block we have declared another variable which is y, and the value of it is 20, which has been assigned into it. Now this y variable is declared within the if block. That means the scope of this y variable is limited to this if block only. Whenever you will come out from the if block, the existence of the y variable will not be there. If you come out from the if block, you can never access the variable y because its scope and lifetime is limited to this if block. So scope will tell you within how much scope or within how much area you can access a variable, and lifetime will tell you within how much area a value of the variable is valid. And here we can see that whenever you will come out from the if block, the value of the variable will not be known because y is declared within the scope of the if block. Now x is declared within main method and if block is declared within main method. So if block can obviously access x. I'm repeating again. X variable is declared within main method and if block is declared within main method. So x, the value of the variable x, can obviously be accessed within if block also. But the vice versa is not true. If a variable is declared within the if block, that variable cannot be accessed from main method because the variable y is declared within the scope of the if block. Its lifetime is limited to this block only. Whenever you will come out from this block, the value of the variable will be invalid. So here we can easily print the value of the two variables x and y. Now let's see this statement. This statement will print the value of the variable x and y by concatenating the two values with a space in between. Now let's see how this statement works. Suppose in a program we have taken two variables, say int a equal to 10, then b equal to 20. And then suppose using a system.out.print statement, we want to print both the values and we want to use a single system.out.print statement. Now obviously you can do it using two statements like this. We don't want to print any text, so we are not using any text that should be enclosed within double quotes. We just want to print the values. Suppose ln is here. So this will give you 10, and in a new line this will give you 20. But what if I want to print both the values in the same line like this, 10, then a space, then 20. If you want to do it, you have to write it like this. The value of the variable a will be taken here because it is not enclosed within double quotes. After that, a plus. So this plus will concatenate this space. This is a space because we want to print the space in between 10 and 20. So this space will be concatenated after the value of the variable a using this plus operator. So within this double quotes, we have used this space because space is a string or text that we are considering it as. So this should be enclosed within double quotes. Now after that space, after this space, we want to concatenate the value of the variable b, which is 20. So for that concatenation, we again have to use another plus operator. So this plus operator will actually concatenate the value of the variable b, that is 20, after this space. So this whole thing will give you the output as 10 space 20. And if you want to print some text before this, you can obviously do it like this: system dot out dot print the values colon double quote ended plus a, then plus a, plus within quote space, then again plus b. So this part is actually this part, and this is just a text that we want to display. That's why we have enclosed it within double quotes. So let's go back to the program. The same thing has happened here. We want to print the text x and y colon, after that a space. That's why we have enclosed it within double quotes. And after this space, we have used a plus operator. That means the value of the variable x will be appended or concatenated after this space. Here also there should be concatenation after this space. The value of the variable x should be concatenated after this space. So that concatenation is done using this plus operator. After this value of the variable x, a space will be concatenated. That concatenation is done using this plus operator. After this value of, after this space, the value of the y variable, which is 20, should be concatenated, and that concatenation is done using this plus operator. Now in the next statement, the value of x and x is modified. X is equal to y into 2. Now y is 20, so x now contains 40. If block ended. Now we want to assign a value 100 into the y variable. But y variable is not known here because y variable has been defined inside the if block. And outside the if block, I have already told that whenever you will come out from the if block, the value of the variable y will not be known. It will be invalid because the scope of the variable y is limited to if block only. So y variable is not known here, and if you still want to access it, and if you still want to give some value into it, it will give you error, compile time error. So this statement will actually give you error. So here you are means that you are within main method again. You have come out from the if block, so you are within main method again. So inside the main method, the x variable is still accessible because you have declared the x variable inside the main method itself. So if you want to print the value of x here, you can still print it. It will not give you any error. So this is the whole explanation of this program. And this is how the scope and lifetime of any variable works in Java language. Now in this program, you have seen multiple statements like this: known to all code within main, start new scope, known only to this block, and so on. And all of them are commented. You have already used comments in C and C++ languages. The same way of using comments is valid in Java language also. If you are using a single line comment, you have to use two front slashes like this. And if you want to use multi-line comments, then you have to use front slash, then a star, then after the finishing of the comment, you will be using the exact opposite thing, star or asterisk, then a front slash again. So this is multi-line comment and this is single line comments that you have already learned in C or C++ languages. These things are valid in Java language also. So this is all about today's lectures. In the next lecture, we will be learning the type conversion and typecasting of Java. Thank you for listening to today's lecture.